the question that CIOs normally ask is, okay, so how do we do this now? So we heard about the challenges and where we believe the value lies, which is ultimately in gaining insights from all this data. But where do we start, and how does that solution look? Because it's quite a difficult journey if you start with the wrong architecture. So we believe that the correct architecture consists of different things. So when we talk about the edge, we talk about all these things that we said now. It's anything from a person wearing a tag to a vehicle to subsystems, security systems, IP devices, but sometimes it's dumb stuff like a switch or a button or a light. Now, ideally, you want to make sure that whatever you implement in terms of an IoT platform and architecture, you want to be able to, number one, go and retrofit onto your old investments. I mean, all these businesses have... Okay, so by the way, we love living on the edge. So this whole thing is lively wired, and it's a live demo. So some of it will work, hopefully most of it. So that was something cool. Anyway, so on the edge, we've got all these different things, and you want to go and make sure that you're able to leverage your existing infrastructure. Now, that consists of old SCADA systems and PLC systems in the factories. That you've got digital systems, subsystems, Windows, DOS-based stuff, all of that. So number one, your architecture has to be able to work with that stuff without having to go rip and replace everything. Number two, you want to make sure that these things can speak to each other. So you want to make sure that that you're able to use a Bosch camera, but then next week, if there's a really good Hikvision camera, you want to plug that into the system. So you want to make sure you don't get locked into an edge OEM framework. So a lot of these guys have great systems where the OEM would provide you with an end-to-end IT solution, but you have to use their cameras or their biometric systems or whatever. And as an organization, you don't want to be locked into that. So your edge architecture, whatever you deploy, you want to be able to future-proof your business, to get to a point where if there's new tech in 6 months' time, you can just plug that into your same framework without having to go and replace the entire infrastructure. So that's the edge side. That's the key component. The next component is, in terms of enterprise, there's a massive push by the big brands like IBM, Microsoft, and the likes. So they're developing these great IoT frameworks, but again, you're locked into their tech. So now you have to use their cloud services, and then they provide you with some of the middle components. What we're saying is the correct architecture should allow you to use whatever you want. So you would want to send some of the data into a great machine learning algorithm that maybe resides in IBM, but you already deployed maybe a dashboard system that sits in Microsoft. So at the same time, you want the data to go into Azure and into SAP and into all those different things. Okay, so the first component to achieve that would be having a great edge gateway architecture. So what we're saying is you need a device at the edge that can link into all these different edge devices, that can collect that data, whether it is old systems, new systems, whether it's analog, digital, SCADA systems, whatever. You want to plug that into your edge, and by having a single technology do that, there's a couple of things that you achieve automatically. So number one, let's say you're a big organization like Eskom or Transnet or so on, and you eventually go in the wrong architecture path, you're going to end up with maybe 15, 20, 30 edge gateway technologies. How do you secure that? How do you maintain it? How do you actually update it with just the firmware and just the logistics and the practicality, the human resources to do that? So what you want to try and do is end up with a single agnostic gateway that can connect into all the edge devices. There must be some intelligence on that edge device. So like Louis said previously, you don't want to send, if you're monitoring an oximeter on an incubator in a hospital, you don't want to send the data, okay, cool, we need some oxygen, into the cloud and rely on the internet and all the processes there to just switch on the oxygen flow and hope that the baby will be okay. That has to reside on the edge. Your edge computer needs to, your edge gateway needs to make the decision, action, that business logic needs to reside right there on the edge. Number two, the other issue that we're all going to have in 5 years' time, 6 years' time is, imagine we've got 20 billion devices, all sending data every millisecond into the cloud. I mean, how are we actually going to get the data there? How are we going to work with that amount of data? You don't want that. Your edge gateway needs to be able to filter that data, to say, okay, cool, if it's in threshold, I want to monitor this room temperature. I want it to be between 20 and 21 degrees. So if it's in that threshold, I don't need to send all that data up. I mean, I can re-simulate it if I need it. But essentially, I want I want to send up the anomalies. I want to say, okay, cool, it went out of threshold. Now there's a whole lot of stuff that's happening. So your edge gateway needs to be able to filter that data. And also it needs to be able to work offline sometimes and collect the data, persist it, and then sync up when you've got connectivity. So the edge gateway is critical in terms of security, in terms of filtering, in terms of aggregation, and in terms of just basic intelligence on the edge. The next component is, like Louis already touched on, is abstracting that data, normalizing it. So all these edge devices speak different languages. So you obviously want to get that data into a normalized fashion so that the analysts don't spend 80% of their time trying to figure out what's going on. So from this layer, you can then directly link into SAP or directly link into your different systems. The next component, which we believe is critical, is having a real-time, practical, operational view of what's going on. So you've got all these edge devices. Now someone is going to manage it on a day-to-day basis. So operationally, you want to create like a digital twin of what's happening on the edge. Now I'm going to show you some of that right now. But essentially, that needs to be a two-way system where you can monitor what's going on the edge and also act on it. If something needs to happen, press a button, affect it. But that has to be remote. Okay, and then finally, you have to have intelligence in this ecosystem. You want to have business rules that says that based on certain criteria, you want to send some of the data into Azure, you want to place an order in SAP, you want to fulfill something, you want to start a whole acquisition process in one of the different cloud systems, you want to communicate back to these systems, you want to tell some of the gateways to switch on devices and switch that off. So that, I mean, there's a lot of enterprise workflow systems. Ideally, you want this to reside on the edge in order to have real-time operational influence over your edge, okay, and communicate that data into the enterprise. So essentially, this is the framework that we want. This is the solution. It has to be scalable, but it has to have the correct architecture. Otherwise, in 2, 3, 4, 5 years' time, it's going to be really tough to have an agnostic platform that's able to cater for all these things that we spoke about. Okay, so now that you've had all the theory, I'm going to show you some practical things on how this gets put into play. So there's my assistant jumping into this. Okay, great. So we're going to do this one first. Okay, so what I've created over here is an environment that beeped just now. So it should still be okay. Great. And I've got some analog devices connected to this. You see we actually built this morning, and we built a visualization tool to show how this works. Okay, so I've loaded our Office as an operational visualization, and now I've got simulations here with physical analog switches that will open and close doors and will give you my environment. So firstly, it's plotted in a user-friendly way that people can understand which facility they're working with. So if we can maybe go into the Office setup, and this is live. So, great. Okay, so that's now our Office, and what I've done here is I've simulated some devices that's connected to the Office. It's got some vibration sensors, it's got some fuel levels, it's got a weightometer, a manual one. I can just press that button, it should be going up. Great, it went from 5 to 6 there in the middle. Okay, and I must just reset my vibration. And there's a very good-looking guy walking into our boardroom. Great. Okay, so this is all good and well, and there's lots of systems that can visualize it. So now what we want to do is just have some intelligence built on this. So I'm going to illustrate how a workflow would work in this environment. So I am going to press this button, and the door should open automatically. So you see there in the middle, the boardroom door open. Now it at the same time triggered a workflow. Okay, so if you can go to the workflow. Okay. Okay, so the door opened, and now if you can go over to the workflow for me, Steve. Okay, so now the workflow is expecting some extra actions. Okay, so I open the door, it's expecting a vibration and the fuel level to drop, and it's going to happen any second now. We're just busy feeding the raptors there. Okay, and the magicians. Give it another second, and then, okay. Enjoying the awkward silences. Okay, great. So let me just close that door, and now I am going to reopen the door. So now it will hopefully, there we go. So there's a workflow. Now it's expecting a drop in my fuel level. So this is an analog device that would simulate that. So, great. Okay. Go back to the screen to just see the fuel level, Steve. Here we go. Okay, so there I'm dropping the fuel level, and I'm going to simulate a vibration, and that's where the beep came from. So now it's communicating. So all of this went via the cloud to the visualization, and it sent me an SMS, but I was told to switch off my phone, so that doesn't work now. And then it communicated back to this device saying, okay, cool, sound the alarm. So that's now just a theoretical model on connecting analog stuff, communicating via the cloud, visualizing it, activating a workflow, and then closing the loop. Okay, so now a little bit of a more sexy example. So can we take the tablet and maybe take it to anybody in the audience, please, Steve? So what we've done, what do you guys see here? You would think it's a coffee machine, but it is. So, so it used to be a normal analog coffee machine, and we've IoT'd the hell out of that thing. So we've connected like proximity sensors, we've connected, and we didn't hook into the circuit board specifically to make it analog. So we added a bunch of devices to this thing and sensors, and we visualized it. So on there you can see in real time what my coffee level is, and it's low. So that might be a problem. It's visualizing over here that there's a red tray. Okay, it's also connecting the, have you got the tablet to someone yet?
Let's log in.
Okay, great. There we go, something moved there. Vibrations, humidity, temperature sensors, all of that stuff, okay? And now we've connected it to the cloud via an app that would, someone can now order some coffee. And it's really good coffee. It's real. So this is where the two-speed world comes into play. It's a physical thing that we take, that we can taste, that we can experience, and we're taking it through this whole ecosystem of connecting it, visualizing it, interacting with people, and two-way communicating. Okay, great. There's already a queue of people that's waiting for their coffee, but it's not going to serve the coffee until I detect the cup there. So maybe, Steve, you can then take a cup, and it should be saying what it's going to serve. So over here, my visualization should say what's coming up next. And then I'll pour some coffee for the gentleman. Then what I'll do is I'll send him SMS and ask him if it was okay, and based on that, we will either tweet that it was okay or not tweet at all. Okay? And this is all seamless. So any second now. Okay. Soon. Going very soon. Okay. It's busy just finding the beans in there and then connecting it all up. Like I said, we love living on the edge, physically, literally. Okay. So while that's busy figuring out what to do, I'm going to show you two, now taking the same concept to more of an industrial, so if you can go back to the Prezzo, please. Ah, there we go. It's busy serving the next guy in the queue now. So it worked. I told you it will work. Okay, excellent. Shoo. Wow. Okay. So now taking that exact theoretical model that we discussed, then moved over to like how to set it up and a practical use case. Obviously, this will not necessarily change the world. It might feed us, but it's not going to change the world. But now taking that exact same concept, okay. If you can maybe just start that. Okay, so what we've done here, this is actually a live site of ours. Okay, and what we did over here is take a mine where they extract coal. It's a coal mine From the pit, we do stock takes with a drone daily. So we take photographs of the stockpiles. We do basically assessment, and then do a calculation on the stockpiles. And then they had 4 different production plants, which are old conveyor belts with 40-year-old weightometers that clicks every ton. We physically went and connected 2 wires to all those weightometers, plugged it into a Raptor, and now we got a live production. So you see over here, 195 tons per hour. The previous hour was 182 tons. Connecting all these different things, and then doing stock takes daily again on the output. So these are the after the stuff has been beneficiated, and then we connected the subsystem that managed the weigh bridges. Now it's a pretty simple exercise that took 6 weeks, but it's a phenomenal business impact because number one, now they used to get this data every 21 days. They would send out someone to site with a spreadsheet and go count the weights that went over every conveyor belt. Now we got that in real time, visualizing it to the mine manager. We then also at the same time close the loop in terms of just the basic math. So we know what we have in pre-production, in beneficiation, the stock afterwards, and what goes out the gate should add up in basic math. And I mean, amazingly, it doesn't. Because the trucks come in with water, and then you put in coal, and it displaces the water, and you take some coal there, and then there's some labor issues where the guys work really slowly the first 20 days and then get overtime. And amazing things that were discovered by just all that we did is connecting all the things on this mine in real time, visualize it, and then report on it. And the impact is phenomenal. So that's one use case that we got live at the moment. The next thing is completely different, but the same software. So we took this is a VW dealership. Steve, again, if you can just maybe start that. Okay, and the issue in South Africa is that the dealerships don't have the same productivity as in Europe. So VW in Europe would have maybe for a 10,000 square meter facility, they would service 100 cars a day. In South Africa, with the same facility, we can only service 50 cars a day. And there's clocking systems where the mechanic would say, okay, I'm starting now, and I'm finishing now, and we just can't get to the real value. So all that we did over years, as a car drives in, we got number plate recognition. So we recognize a car's coming in. It ties into the dealer management system. So it says it's Andre that's here today with a Polo, and the Polo is here for a 15,000K service. So we immediately tag the car has arrived. We add a little RFID tag in the car. Now we track him like GPS in the dealership. So now we know before he can service it, has to go to pre-wash. So we put workflow on that. So now we track the car between coming in to the wash area. And then as it gets to the lift to get serviced, we don't rely on someone to press a button. We know the car's there, so we start the clock immediately. And now that ties into the dealer system that says this service is supposed to take 2 hours. So while it's green, it means it's in spec, so the service advisor can see in real time, hey, this stuff is working really well. Or if it goes into orange, it means that it's over threshold. Now we can actually switch on the camera and see, and the guy's probably having a smoke or waiting for parts or whatever. Okay, and then the process goes through a basic workflow because it's always the same thing. You come in, pre-wash, you service the car, you wash it afterwards, there's a quality check, and then invoicing. So we all know when you get there at 4 o'clock, the service advisors run to the poor invoicing clerk with a stack this high of job cards, and now she's trying to push through it. So what we do now is right after the car is serviced, we already alert the service advisor to take it to QC, and then immediately to take it to invoicing. So that the business goal here was to try and service 2 cars per day more, which is pretty simple now because there's so much visualization on all of this. So a practical example of exactly what we just did here, connecting real life things in a business, operational technology, tying it in, and then escalating it and doing that whole ecosystem that we were talking about. So that's it from my side, I think.